All right, so AI agents, they're getting crazy powerful, right? We're asking them to do these massive, complex projects that can take hours or even stretch over several days. But there's this one huge problem, this one critical flaw that's really holding them back. So let's dive in and break down exactly what that is. So here's the big question. Can you actually hand a top-of-the-line AI agent a really complex coding project and just, let it run for days until it's done? I mean, it feels like we should be at that point, doesn't it?
Yeah, the answer, for now at least, is a big fat no. And it all boils down to one simple but absolutely massive problem: memory.
And this gets us to what the folks at Anthropic call the long-running agent problem. See, because of how context windows work, an agent has to do its job in these separate chunks, or sessions. But here's the kicker. Every time a new session starts, poof, it has zero memory of what it just did. The analogy they use is just perfect. It's like an engineer showing up for their shift with complete amnesia. They have no clue what the person before them just spent hours working on.
So what does this AI amnesia actually look like when the rubber hits the road? Well, let's take a look at what happened when researchers put one of these top-tier agents to the test.
The experiment was pretty simple but really ambitious. The researchers gave a frontier AI model a super high-level prompt. Just go build a clone of Claude.ai. Now, that's not a trivial task, right? It requires a ton of logical, sustained effort over a long, long time. And yeah, it didn't take long for things to go wrong, and in some really predictable ways. First, it would try to do way too much at once, like build the whole app in one shot. It'd run out of context and just stop, mid-task, leaving behind this total mess of half-implemented, undocumented code. So what happens in the next session? Well, the agent spends the entire time just trying to clean up its own mess. Or, and this is a classic, it'll make a tiny bit of progress, look at what it did, and basically say, yep, looks good, the whole thing's done.
So the takeaway here is this really stark contrast. The goal was this beautiful production-quality web app. What they actually got was a buggy, half-finished disaster. It just goes to show that raw coding power is not enough. The agent needs a smarter way to work.
So if the AI agent can't figure this out on its own, where do we even start to look for a solution? Well, it turns out the answer is us. And this right here is the big aha moment. The solution wasn't some crazy new algorithm. No, it was about teaching the AI to work like a really good, disciplined human software engineer. Using all the stuff we use every day. Structured processes, good documentation, version control, the whole shebang.
Okay, so how in the world do you teach an AI to work like a human? Well, Anthropic came up with this really clever two-part system.
They basically split the job between two different specialized agents. You've got an initializer agent that runs only one time, right at the beginning, to plan everything and set up the whole workspace. And then you have a coding agent that comes in for every session after that, and its only job is to make small, steady, incremental progress.
Think of the initializer agent like a project lead. It doesn't actually write the app's code. Instead, its job is to lay the groundwork. It creates a super detailed feature list, sets up a progress log, makes a simple script to run the app, and then makes that first git commit. It's basically getting the entire project ready for all the work that's about to happen.
Okay, so that feature list, that is the secret weapon. It's what stops the agent from just quitting too early. It's basically a structured JSON file that takes this huge, vague goal, build a website, and smashes it into hundreds of tiny, specific tasks. And here's the genius part. Every single one of those tasks is initially marked as failing. It's literally a to-do list that the agent has to work through, one checkmark at a time.
So now, with that whole setup in place, the coding agent can start each session like a real pro. Instead of waking up with amnesia, it has a process. First, it checks where it is. Then it reads the Git history and the progress notes to catch up on what happened last. And finally, it looks at that feature list and picks the next thing to work on. No more fumbling around in the dark.
And listen, starting smart is one thing, but finishing smart is just as important. At the end of every session, the system makes the agent leave the project in a clean state. That means it has to test its code, log what it did, and commit its changes with a good descriptive message. It's basically cleaning up its workspace for the next person who just happens to be itself in the next session.
And this table just puts it all together perfectly. You can see how every single one of those failure patterns we talked about now has a direct solution. Quitting too early? Nope. That feature list makes it finish the job. Leaving behind a buggy mess? That's what the clean start and end routines are for. And what about marking things as done when they're not? Well, now the agent has to actually prove its work is passing using real browser automation tools. It's a fantastic system.
Okay, so this is obviously a massive step forward. But what does it really mean for the future of these AI agents? Where do we go from here?
Well, this opens up some really cool possibilities. I mean, if a two-agent team works this way, what about a whole crew of specialized agents? You could have one for testing, one for QA, another for refactoring code. And you have to wonder, could we take these same ideas, this structured memory and steady progress, and apply them to totally different fields, like scientific research or complex financial modeling?
And that really leads us to the final, really mind-bending question here. What we're doing is building a kind of perfect external memory for these AIs. So once an AI can remember and learn and build on its own work flawlessly over days, weeks, or even longer, what are the limits? What will it build next?